Okay, so I've been trying to think all day what I'm going to do to make these graphs easier. So I set up your 4 graphs that we're just going to use for your study guide, these 4 graphs. And let's just go through them. I'm thinking instead of dividing everything, we're getting so bogged down in that arithmetic with separating our quadrants, separating our sections for our graph. Let's just make it easy. The only thing we need to know, and if you look at the screen, I uploaded this to your Canvas. It's already worked out, but I wanted to go through this video tonight while you do your homework and while you start playing with it, and I don't want you to be stressed out about it. We're not going to do that. We just want to know what the graphs look like. I want you to understand what phase shift is and what the sine and the cosine graphs look like, okay? So right here where it says state the amplitude, period, and phase shift if it exists, and sketch the graph using the beginning point, ending point, and halfway point. That's all you have to do. If you knew what the basic graph looks like, then you're going to know where it rises to the high point and to the low point on your amplitude. So let's look at these. The first one is y equal 3 sine x. You know what your sine curve's going to do. However, let's go through the 3 aspects of it. The amplitude is this number before your trig function, so it's 3. It's going to rise 3 spots, and it's going to fall 3 places. So you know what your amplitude is. Your period is 2 pi over whatever coefficient this x is. So it's 1. That's your period, 2 pi. Okay, so from 0 to 2 pi, we're graphing this. Those are your 2 endpoints. You know what your middle point is pi. Halfway from 0 to 2 pi is pi. Well, all 3 of those are 0 according to this unit circle, isn't it? The sine of 0, the sine of pi, the sine of 2 pi is all 0. So you need to figure out where it rises. That's fine. You can label it if you want to, but if you just know, if you graph the parent graph, and you know that the first curve is a maximum at that amplitude, the second half of that curve is a minimum at that amplitude, that's good. Just label your amplitude and show me that it's rising in between your first and your midpoint, and show me that it's a minimum between the halfway point and the end point. I am good with that. Don't worry about it. Look at the next one. Let's do the same thing. Amplitude is 4. Right? Your period is going to be 2 pi over 1/2. There's your 2 pi over 1/2. Flip that. Your period is 4 pi. What's your beginning point? 0. What's your midpoint of 4 pi? 2 pi. What's the end point? 4 pi. If you know what you're doing at 0 and 2 pi and 4 pi, which you do, you know what you're doing there. It's all at 0. You know your sine graph starts at 0 and it rises to the amplitude halfway between 0 and 2 pi. This one does because it's sine of 1/2 x. Then between 2 pi and 4 pi, you're at your minimum. So see, it looks just like this first one, except the period is expanded a whole nother 2 pi because of this 1/2 x. That's what that 1/2 does. It expands or stretches the graph. Okay? I'm good with that. You don't even have to label the pi and the 3 pi. Okay, for a phase shift, amplitude is 5. Period is 2 pi over 1. So your period is 2 pi. Your phase shift, let's still do that interval so you know where to write your graph. If you put your phase shift, this whole thing in parentheses, between 0 and 2 pi, you know that your phase shift interval is going to be pi over 3 to 2 pi plus pi over 3. That ends up being 7 pi over 3, okay? So figure out what your halfway point is. If you know your period is 2 pi, what is the halfway point of 2 pi? Is pi, right? So you can add pi to pi over 3, and that'll give you 4 pi over 3. There's your halfway point. You know what your sine curve is doing. I didn't even label those points If you look, it looks just like all these other sine curves. It's just starting at pi over 3 because it's shifted to the right. There's your upper end. Your halfway point comes back down at 0. Then you have your minimum showing, and it comes back up at the end of your period, or 7 pi over 3. I'm good with that. That's good. So again, the amplitude, the period, your phase shift interval. And you know that half of your period is pi, so just add pi to your bottom where your phase shift starts. All right, and then the next one is a cosine curve. So you have to know what your cosine curve does. At 0, cosine, according to our unit circle, at 0, cosine is 1. So over here, it's going to be up here. So your normal curve would be down here. However, we have a phase shift of pi over 3. So we're moving to the right, pi over 3. Your amplitude is 2. The period is 2 pi over 2, which is just pi. So we're just going from 0 to pi. So only 1 pi, or half a circle, is the whole period. That's where the cycle ends. However, we've got a phase shift. So set this whole quantity in between 0 and 2 pi. And your interval for your phase shift after all this divided by 2, you've got pi over 6 all the way to 7 pi over 6. So label those 2 points, find your halfway point. Your halfway point of pi, half of pi is pi over 2. So add pi over 2 to the lowest boundary of your interval, and you're going to see you get 4 pi over 6, or what, 2 pi over 3, whatever. But don't even worry about all that. Just label it. Move it over and just graph your big bow or your cosine curve. I'm good with that. So ending point, middle point, beginning point for your 3 points. You have to know what your curve is doing, but I'll know you know if you come up and down to your amplitude. Okay, so maybe that's going to be a little bit easier for you. I should have done that in the first place. We just got all bogged down. Sorry about that. I just need to make it easy. You just need to know what we're doing and what the curves look like. So just kind of calm down. Don't worry about it, and just give me about 3 points on your graph, okay? So practice that. I'm going to email this to you, give you instructions on how to get to this video as well. Okay, see you tomorrow. We're going to start on identities.